Alright, welcome to the last example where we're going to find the solution to the second order linear differential equation where our right side is e to the t arctangent t. So again, we're not able to do undetermined coefficients because of what the right hand side looks like. So initially we're going to solve for the homogeneous part. So we're going to set y double prime minus 2y prime plus y equal to 0. So when we do that, we can go ahead and say m squared minus 2m plus 1 equals 0. We solve for m. We're going to get m minus 1 squared equals 0, where m sub 1 and m sub 2 both equal the same value, which is 1. So our complementary solution is going to be c sub 1 e to the t plus c sub 2 t e to the t, because our zeros for m repeated, so therefore that's why I have t e to the t. So there's our complementary solution. And so also from here we can find out what our y sub 1 is. Our y sub 1 is e to the t, and our y sub 2 is t e to the t. Now we can go ahead and develop our Wronskian, because we know that our solution for the Wronskian is going to be when we set everything up, it's going to be 0, and then f of x, which is e to the t arctan t for f of x. So let's go ahead and set up the Wronskian. When we set up the Wronskian for this, we're going to go ahead and write our y sub 1 and y sub 2's. So y sub 1 is e to the t, derivative of e to the t is e to the t. Y sub 2 is t e to the t, derivative of that is t plus t e to the t. So once we do that, we're going to multiply through. So when we multiply e to the t times e to the t plus t e to the t, we get e to the 2t plus t e to the 2t. And then when we multiply t e to the t times e to the t, we have minus t e to the 2t. Hopefully you noticed that on the right we have e to the 2t minus e to the 2t. Hopefully I didn't undo too much. I think I did a lot. Just wait until I find my next highlight. There we go. Get rid of that highlight. Alright, so we fixed everything. We are finished with e to the 2t. So that's what our Wronskian equals, e to the 2t. Now, our Wronskian sub 1 is going to be 0 e to the t arctan t for that first column, and that second column, so it's going to keep the Wronskian. So we're going to multiply. What's nice about our w sub 1, w sub 2 is we're always going to have a 0. That's going to give me 0, then minus these two terms, all right, which is going to be minus t e to the 2t arctangent t. So that's our Wronskian sub 1. All right, our Wronskian sub 2, we can go ahead and find that as well. Multiply those two. Our second part is going to be 0, so it's just going to be e to the 2t arctangent t. All right, so that's easy. Now we got to get to the integration. All right, we find out what our u sub 1 prime is. That's just our Wronskian sub 1 over our Wronskian. And this is what we get. Now, what we want to find is u sub 1. So we're going to integrate all of this. So I'm going to clean this up a little bit. Hopefully you notice that e to the 2t and the e to the 2 cancel out. So we're just left with negative t arctan t is what we're going to have to integrate. We have a negative, so I'm just going to pull the negative out. So based off of this, I'm going to have to use separation of variables to take the integral. So u is arctangent t. So then du is going to be 1 over 1 plus t squared. I should say, let me clean this up a little bit because I have some x's in there. Because I'm used to dealing with x's and not t's. Let's just make that a t, make that a t. Let's do that real fast. Alright, and then so we have our u's and our v's. We do some u substitution, and then now we get what's over here on the right hand side. So we do u substitution, and then we substitute in. Now, we go ahead, uv is right here, so that's going to be our first part. There's uv, and then minus, I can actually clean that up too. I should just say t. All right, minus RV times du. And what I'm going to do is, and then I just got to simplify this. So again, now it's just, back to some Calc 2. Go ahead and pull out a 1/2 and off a t squared, 1 plus t squared. All right, this side over here, the left-hand side, don't have to worry about it at all. Bring down, so right here, since I have t squared plus, and then 1 plus t squared, I'm going to add 1 minus 1, so I get t squared plus 1 minus 1. So then this part will just give me 1, and then the second part is going to be 1 over t squared plus 1. Integrate the 1, it's just going to be t. That's nice. Integrate in this part right here, it's just going to be arctangent of t. Alright, and so once I have all that, I actually have my u sub 1. And I'm going to get 1/2 t minus t squared plus 1 over t arctangent t. So there's going to be my u sub 1. I have a u sub 2 that I need to find, which is going to be first given by u sub 2 prime, which is the Wronskian sub 2 divided by the Wronskian. Go ahead and plug that in and get e to the 2t arctangent t divided by e to the 2t. E to the 2t's cancel out. I just got to integrate arctangent t dt. Again, you probably haven't integrated arctangent t. Again, go to your calculus textbook, your differential equations textbook, go to the page, go to the sections where they have all your little integrals worked out for you, and you're going to find that your integral of arctangent t is just t arctangent t minus 1/2 natural log 1 plus t squared. We found our u sub 2's, our u sub 1's. Now we go ahead and plug it in. U sub 1 times y sub 1, u sub 2 times y sub 2, and then combine it with your complementary solution to find your final solution. There's the complementary part, and then there's just the particular part rewritten. And so we're finished. All right. And again, these are long. That's why I'll go ahead and kind of drew these out for you, just because it would take a long time to explain these. And so there's our final answer, and we're done. All right. I hope you all have enjoyed today, and it's a nice little comeback to it's only 2 problems that you have to do. I'm gonna give you like 3 or 4 to do.